This lesson is about simple circuits, and one of the first things you want to think about is why does current flow in a circuit? Well, when there is a potential difference from one side of the battery to the other, then that's kind of like having a difference of potential energy from, say, one height to another height. So because there's a difference in potential energy, that potential is going to want to be released. So just as a child can slide down a slide, an electron with a lot of electric potential energy per unit charge is going to want to flow or fall to a place that has lower potential. One of the basic circuit elements is called a resistor. What a resistor does is it impedes flow of electrical current. So we can use resistors to manipulate how much electric flow we want to go to certain parts of our circuit. The amount of resistance that a resistor offers has to do with three factors. The amount of resistivity, which is specific to the metal, the length of the resistor, and the area of its coaxial surface. Let us now examine the effects of lengths of resistors. So if you were an electron and you had just finished shopping for groceries, and you have a choice between three different lanes to pick, and those different lanes all have different lengths of how long the line is. This one might take a lot longer for you to get through. That doesn't look too pleasant. Well, we could get through here, but you're probably going to pick the shortest line because that would be the easiest for you to flow through. The shortest length of a resistor is going to have the least amount of resistive material getting in your way. Now let's consider how we would add resistance if we had multiple resistors that we had to go through. So say you have two resistors side by side, one right after another. You have no choice. You must go through both. So that's kind of like adding length. And looking back at our equation, it would be like having two different L1 and L2 added together. So the resulting formula for adding resistors in series becomes R total equals R1 plus R2 plus R3, however many you have. It's simple addition. Here's an example of a schematic of a simple series circuit with two resistors. Notice there was only one wire, only one lane to travel through. There are no choices. You must go through both resistors. So adding resistors in this fashion is a way of increasing total amount of resistance. Now let's consider the effect of, instead of increasing length, increasing area. If you have a greater amount of area, you're going to have more room for more electrons to flow through, kind of like if you have more lanes on a highway. And if you have less area, you're going to have less room for less flow. Now consider the algebraic implications for changing our total area. If we were to add two resistors that are instead of one right after another, but we add a choice, so it could go through one or the other, that's kind of like we are increasing the amount of area available for electrons to flow. So in our equation, it's as if A gets bigger. So total resistance would go down if we added resistors in this fashion. And in our formula, if we flip it upside down, we get an equation for adding resistors in parallel. 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3, and however many you have in parallel. Here's an example of what a simple circuit of two resistors in parallel looks like. Notice there are two different paths that an electron could take. It could go through the first resistor, or it could go through the second resistor. Let's try an example of adding resistors that are both in series and in parallel. To do this, we're going to reduce the circuit by finding equivalent resistance of small parts of it. For example, the two 5s that you have, that's equivalent to one 10 ohm resistor. So the circuit can be redrawn. Note, we now have a 10 ohm resistor in place of the two 5s that were in series. Now let's take a look at these two 10 ohm resistors. They are in parallel. So how do we add resistors in parallel? We have to do 1 over R total is equal to 1 over R1 plus 1 over R2. In this case, R1 and R2 are both 10. So we have 1 over 10 plus 1 over 10, which gives us 1/5. So 1/5 would be 1 over R total, so together those two resistors act as a 5 ohm resistor. We can now redraw the circuit once again to look even more simple. Our simplified diagram now just has a 10 ohm resistor in series with a 5 ohm resistor. Lastly, we want to add those resistors in series. Now remember, adding in series is just additive. So R1 plus R2, 10 ohms plus 5 ohms. That's going to equal 15 ohms. So our total equivalent resistance of the entire circuit is 15 ohms. Let's zoom out for you so you can see the math and how it was reduced. Those two 5s turn into a 10, the two 10s in parallel turn into a 5, and lastly the 10 and the 5 in series turn into a total of 15. Well, this has been Adding Resistors with MrHphysics. I hope you enjoyed the lesson.